Thank you very much, Terry. I'm here at Jordan Hall of Science in the Digital Visualization Theater. We're here with Justin Crepp and Keith Davis, two professors here in the Freeman School of Physics. Now, Justin, as we get into the Digital Visualization Theater here, what do astrophysicists actually do? What is your job involved here at the university?
Right, so I teach classes, obviously, and in addition to that, we do research, and in particular, we travel quite a lot. We go to telescopes all around the world. We use telescopes on the ground, we use telescopes in space, and in particular, Notre Dame has access to the largest telescope in the world, the Large Binocular Telescope in Arizona, two 8.4-meter dishes that we train on the deepest, darkest patches of sky, and we study the cosmos. We study stars and planets and galaxies, and we try to make sense of how the physics of the cosmos works, and then we collect that data and we transfer it to our computers. We bring it back here to Notre Dame, and we process the images, we process the spectra, and we then share that information with our students. And the Digital Video Theater, where we are right here in Jordan Hall, is the ideal place to kind of share this research and teaching interface with our students, because we can visualize all of our data sets in 3 dimensions. We can have a full proper rendering here on the sky, and we can fly through the data in real time. We can teach, we can stop the images, the movies, we can ask questions and query the students and make sure that they really understand what astronomers do and the kind of questions that we're trying to tackle. So this digital video theater is just a wonderful resource to really share what we're doing when we're not teaching, even when we are teaching.
Absolutely. So you mentioned the teaching aspect, and certainly a vast universe out there. I'm sure you're up a lot of late nights exploring it, but what does your research actually entail?
Right. So I am the first professor at Notre Dame that has a lab, and so we actually build things in the lab. We build new instruments for these telescopes so that we can explore the universe in new ways, so that we can have new eyes in some sense. And so what I do in particular after we build these instruments is to search for planets orbiting other stars, right? So-called extrasolar planets, right? We have 8 planets in our solar system, if you don't count Pluto, and it turns out there are many planets orbiting other stars. This is a profound discovery that we just made within the last 10 years. We now know that the galaxy is teeming with worlds that are somewhat like our own.
So you mentioned that, and I'm not going to ask you whether there's life on other planets here this evening, but what's the most exciting discovery other than that you've been able to make here at the university?
Right. So the most exciting thing that we do is we try to look for planets that might pass in front of their star. They might periodically dim the star. We can measure that decrease in flux with very precisely, and so we can find planets that are about the same size as the Earth in periods where they might be in the so-called habitable zone, where the conditions may be conducive to the formation of life. And the most exciting discovery that we've made, there's several of them, but Kepler 186, I would say, is a particularly intriguing system. It has 5 planets that are about the same size as the Earth, and 2 of them are in or near the habitable zone, and so they may have life. We don't know. That star is really far away. Ironically, we're finding the ones further away than closer. And so the next step is to look at the planets that are orbiting the closest stars. We know they must be there, and Notre Dame is leading the way for trying to figure out, to build instruments, how we can characterize these worlds, these remote worlds, these very distant worlds in exquisite detail.
That's pretty amazing, Justin. And then just here at the university and Jordan Hall in general, talk about the resource that this DVT provides you here in Jordan Hall. How does this assist you in your research?
Right. So, in addition to teaching, we can bring the data here, as I mentioned, and do these renderings where we can actually get, we do quantitative things all the time, but it really helps to get a qualitative feel for the data that you actually gather at the telescope so you can properly understand it.
And you talked a little bit about the Kepler mission, obviously the implications that provides, but can you go in a little bit more into that Kepler mission and expand on it a little bit?
Right. So the Kepler mission looked at a small patch of sky with 150,000 stars all in the same area, and it was looking for ones that would blink on and off periodically. We figure out the statistics of exoplanets from that mission, and now that's how we know that these worlds must be nearby.
Pretty amazing interview here at the DVT in Jordan Hall. Justin Crepp, thank you so much. We also would like to thank Keith Davis, but now let's send it back in the studio for Notre Dame Day and go back to Maureen McFadden.